Welcome back to the MATLAB tutorial series. In the previous video, we learned how to create and modify arrays. Today, we'll take the next step, exploring some of MATLAB's most useful array and matrix functions. These functions help you analyze, organize, and transform data in just seconds. Let's start with a simple example, finding the maximum, minimum, and average values. Imagine you have a vector of test scores, 70, 85, 92, 60, and 78. The function max returns the highest value, 92. Min gives the lowest, 60. Mean calculates the average, about 77. Now let's see how these work on a matrix. If we arrange these same numbers into two rows, MATLAB gives the maximum and minimum of each column separately. That's really useful for analyzing multiple measurements side by side. Sorting is another essential operation. Suppose you have a vector of numbers, 10, 40, 20, 50, and 30. The sort function arranges them from smallest to largest. If you add an option for descending order, MATLAB flips them the other way around. Now imagine a small table of data, a matrix where each row is a student and each column is a score. Using sortrows, we can sort the entire matrix based on any column. For example, by the second column to rank students by their second test score. Sortrows is incredibly powerful when working with datasets because it preserves the connection between columns while sorting. Typing long vectors manually is no fun. MATLAB can generate them automatically. The colon operator creates a sequence with a specific step. For example, 1, 2, 9 makes a vector 1, 3, 5, 7, 9. There's also linspace, which stands for linear spacing. Instead of a fixed step, you tell MATLAB how many points you want. For instance, linspace from 0 to 1 with 5 points gives 0, 0.25, 0.5, 0.75, and 1. These are perfect for plotting, simulations, or defining input ranges. Now let's look at matrix-specific functions. We'll create a simple 2x2 matrix with values 1, 2, 3, and 4. The sum function adds the elements of each column. If you apply sum again to that result, you get the total sum of all elements. The transpose function flips the matrix across its diagonal, turning rows into columns. And the in function calculates the inverse matrix, the matrix that, when multiplied by the original, gives the identity matrix. This is a key concept in linear algebra and system solving, and MATLAB makes it effortless. Finally, let's combine what we've learned. We'll create a vector of random integers using randi. Then we'll sort them. find the average, and calculate how far each value is from that average. By comparing each element to the mean, we can instantly see which values are above or below average. A simple example of data analysis using just a few lines of MATLAB code. Let's review. We used max, min, and mean to summarize data. We learned how to sort vectors and matrices. We created evenly spaced vectors using the colon operator and linspace. We explored matrix functions like sum, transpose, and inv. And finally, we combined these techniques to analyze random data. These are some of the most useful MATLAB functions for real-world problems. If you enjoyed this video, please like, comment, and subscribe for more hands-on MATLAB lessons. Thanks for watching, and see you next time.